Hey guys, Mr. Midas is here, and this is lesson 4-1 for Essentials of Calculus. So in this video, I'm going to talk about absolute and relative extrema. So extrema means max and mins, and what we're going to do is we're going to use a derivative to determine if we have a max or a minimum value. We're also going to look at the mean value theorem. I think I'm going to do that in a second video, so stay tuned for that one. But for now, let's go and get started on relative extrema, relative and absolute extrema. So here's some definitions that you're going to want to know, and I'm just going to go and let you read over those. So you might want to pause that and then come back. All right. Okay, so here we go. We're going to go and look for our critical numbers first, and we look for our critical numbers by looking to see if f prime is either 0 or undefined. That's our process. So our procedure for finding absolute or global extrema. So we're going to find all critical numbers, again using this idea here to find critical numbers. We're going to find our y values of each critical number and at each endpoint of the interval. Then we're going to choose the least and the greatest y value to tell if that's absolute extrema. All right. So if it's not absolute, then it's a relative extrema. So let's take a look. So just a couple of things. Absolute extrema can occur at either the critical numbers or at the endpoints of our function. Relative extrema can occur only at our critical numbers. So just because our endpoint is an endpoint does not mean it's a relative extrema. It can only be at critical numbers. So let's take a look at a graphical example here. What is the absolute maximum of f? Well, we're looking at the absolute maximum y value of f, and that's at an x value of -4 and a y value of 4. So our absolute maximum of f is 4, right? Because its y value is 4 right there. See, that's the highest it could possibly be. What x value does f have an absolute maximum? Well, we just figured that out. That was x equals -4. What is the absolute maximum point of f? Now we're looking at a point, so we've got to label it as a point, -4, 4. What is the absolute minimum of f? Well, this is a problem because as we follow this graph, you know, it's getting closer and closer and closer to this point right here. Well, this is actually not even a point, it's an open circle. So at 4, -2, the value y equals -2, I don't actually reach that point. I get infinitely closer. So this one doesn't have one. Does not have one. All right, so we do not have a absolute minimum of f. At what x values does f have a relative minimum? So now relative minimum, we're looking at where does it where does it peak going down like this? So we see that there's a peak right here. This is a relative minimum. So that's a point -3 for what x values? So x equals -3. Here's another one right here at x equals 1. And the other one would be right here at x equals 2. That seems weird, but you know, this point being right here, this is a critical number, a critical value, but it's down here, so we call that also a relative minimum. Where does it have a relative maximum? Well, it peaks right here at x equals -1. So that's our maximum. So hopefully that makes sense in terms of graphically what we're talking about in terms of maximum, minimum, maximum values and minimum values. All right, let's continue on and look at some examples here of how we're going to do this calculus-wise. All right, so let's go ahead and find the global extrema. Global means absolute. All right, so global extrema means absolute. Okay, so we're going to do step 1, which is take the derivative. So we're going to get x squared minus 4x. And then we're going to set that equal to 0. Find our critical numbers. So our critical values here are x equals 0 and x equals 4. And that is when our f prime of x equals 0. Okay, so those are our critical numbers. We're looking at the interval -1, 3. X equals 4 is not in that interval, so we're not going to use x equals 4 just because it's not in our interval. So we got to be aware of what interval we're using, all right? Okay, so are there any places where f of x is, or f prime of x is not defined? So is there any place where we have an undefined f prime of x? Well, there's none. So our only critical number for this is x equals 0. So now we're going to take that critical number and we are going to do a few things. For global extrema, we know that we can either be at our critical number or at the endpoints. So we're going to do, what we're going to do here is we're going to plug in -1, because that's our endpoint, into our function. We're going to plug in 0, which is our critical number, into our function. And we're going to plug in 3 into our function, which is another endpoint. And we're going to see which one gives us the biggest value or the smallest value. So this is going to give us -1/3 plus, -2, which is -2 1/3. F of 0 is going to give me 0. And f of 3 is going to give me 9 minus 18, which is -9. So let's take a look at this. Which of these three values is biggest? Well, that's going to be 0 in this case because the other two are negative. So we have a max at x equals 0. So our maximum, our global extrema, would be f of 0 equals 0. All right. And our min is going to be f of 3, because that's going to give me -9, at least on the interval from -1 to 3. All right. Okay, so hopefully that makes sense. We're going to, again, we're going to take it step by step. We're going to find our critical numbers, and then we're going to use our critical numbers to find which ones are our absolute and absolute max and mins. Okay, let's find this one now. Find the absolute max and minimum values of f prime of f of x equals absolute value of x -2 on the interval 0 to 5. Okay, so we know that the absolute value is a function that is not differentiable at the sharp turn, right? So there's a sharp turn right there. So f prime of x doesn't exist at x equals 2 in this case. All I did was draw my absolute value there. Okay, so f prime doesn't exist at x equals 2, so my critical number is x equals 2. So I'm gonna do the same thing I did before. F of 0, f of 2, f of 5. F of 0 is going to give me 2, f of 2 is going to give me 0, and f of 5 is going to give me 3. So I'm going to have a max at f of 5, and I'm going to have a min f of 2 equals 0. Okay, so this is my max value, this is my min value. Remember that a value is our y value. So we're not looking for the x value that's the greatest, we're looking for the y value that gives us the greatest or the least. Find the extrema. Okay, extrema, same thing. I'm just using different words for these so you guys get used to all of those. They'll come up, you know. Find the extrema f of x equals this on that interval. So we're going to first take our derivative, and that's going to give me 2x to the -1/3 minus 2. We're going to set this guy equal to 0. And then I'm going to solve. One equals cube root of x, x equals 1. Okay, what else do we know? Well, we know right here we have something in the denominator, so f prime of x cannot be equal to, x cannot be equal to 0 for f prime, right? Because you've got a domain restriction there. So f prime is undefined and x equals 0. So I got two critical numbers in my interval. I've got my critical numbers are going to be x equals 0 and x equals 1. So I'm going to test all three of these guys, or sorry, I'm going to test four of these guys out. I got to test f of -1, f of 0, f of 1, and f of 3. These are all three of my critical values. So I'm going to plug those values into my original function, and I'm going to get 5, 0, 1, and 3 cube root of 9 minus 6. Okay, which actually is not going to be bigger than 5, but will be bigger than 1. So our max is going to be, our max for f is going to be 5, and our min of f is going to be 0. All right, again, I'm taking the y values as my max and mins there. Okay, so that's it for this video. This is just on using finding critical numbers and finding max and minimum values, or absolute max and minimum values. And on the next video, we'll start looking at the mean value theorem. We'll see you guys soon. Bye.